Okay, students, so let's continue with our next very famous ADT, and that's the queue. And the queue is very interesting because we do this a lot. Okay, the queue is a FIFO structure, which means the first in is going to be the first out. Okay, so while in the stack, the entrance and the exit to the structure are on the same side, in the queue it's in a different side. So new elements go in this way and they get out, the other way. So the best example is a line, to go to the teller, or at the airport, or I love the one at the box office. Okay, all those lines are queues. And of course, just like with the stack, you go in this way, right? Let's say here, and you're going to get out on this way, and you cannot cut in line. At least the rule of a queue, one part of the ADT says that you cannot just go and insert yourself in the middle. There's a way in and there's a way out, right? So we have to keep this in mind, so don't cut in line. So the conceptual view of a queue looks like this. We're going to be adding an element here at the end or at the rear of the queue, and the back of the queue, or the front of the queue is here where you're going to be removing an element. Again, right, if the box office is here, then you're going to be getting in here, but you're going to get out as you get your tickets to go inside the theater. So if we think at the abstract data type, now, while in the stack, when we add an element, we say that we push it in here with the queue, we have the enqueue. So we enqueue an element, meaning that we put it into the queue, we place it into the queue. When we get it out, the name for that is that we dequeue an element. So we enqueue to add, and we dequeue to get out. In the stack, we will peek at the element that was at the top. In the queue, we're going to say first, and that means that we're looking at the first element, at the element that it's next in line to actually get out. We also have the isEmpty method, which is based on size. So as we enqueue elements, we increase the size. As we dequeue them, the size is going to be, a minus size. Okay, so that's how we are going to work with the queue. So you're going to see that it's a different way of doing it, and it's also a different way to implement it if you think about it in a linked list perspective. Now over here, we have the interface, the UML interface of a queue. Now again, right, these methods may or may not match the ones that you have. And as a matter of fact, I would not write it like this. We'll have the enqueue and dequeue, which now you know what they are all about. We have first, isEmpty, and size, and I will not ever implement a toString method in a queue. So if I ask you to write a queue in the interface that I give you, I will not give you a toString, because one of the important parts about this is that you only see the very first element. In the stack, you only see the top element when you peek, right? Something goes in and out, but you don't traverse it, you just look at the top, and would you insert in the back and get out from the front, and so on. So if I were giving you an interface for the queue ADT, I will not give you a toString method. But again, the ADT will depend on the kind of problem that you're trying to solve, and it has to adhere to whatever the specifications adhere to the specifications that they have been given to you as a software engineer. So if we were going to implement a queue using a linked list, right? So we will be getting, somebody out here from the front, but they are going to be inserted through the back, right? So they are going to come in the back and be in line until they will be dequeued from the front. And it's always useful to keep a count. Now, if I were here to enqueue element E, it's going to go right here in the rear, in the back, right? So as we enqueue E, we actually then, our front is the same, but our count actually changes, right? So if I dequeue an element, I would have dequeued somebody from the front, in this case the letter A, and E remains there because it has to take its turn, because we are going to be dequeuing from the front. And again, you know, your count is 4. So please remember the methods that you use for queuing. For queuing, for enqueuing, we are going to add the element. To dequeue, we just take the one from the front. This enqueuing happens in the back. Dequeuing is in the front. First, just looks at the next element, the element in the front, the element that is next to be out is empty, just tells us if the queue has any elements, and it's based on size, which is a count of the elements, and we keep that always updated as we enqueue or dequeue elements from the queue.